Okay, today what we want to talk about for a few minutes here, Chapter 9, VLANs. VLANs, Virtual Local Area Networks. When you see VLAN, think subnet. It's like we would have taken a switch, an entire switch. If we wanted to have 3 VLANs, for instance, as I not finish this sentence, we're going to take the switches and break them up. This would be, instead of, if we wanted 3 different VLANs, having 3 separate 24-port switches, for instance, and then connect them to different interfaces on a router in order to communicate between those different subnets that we connected to the switch. We're going to take the switch and break it up into virtual local area networks, virtual switches, if you would prefer. We're going to have some slides. Some of them are for this. Some of them I got from other areas, other places to try to show what these things actually do. But we could use VLANs in this building. We could use VLANs in this room. We could create VLANs on that switch back there that said, hey, most of the ports in the VLAN, or maybe VLAN 111, room 111, but take the instructor computer and put it in a VLAN 12 or whatever, and they're going to have numbers. We'll go through that in a few minutes, so that the instructor machine is actually on a different subnet than the faculty machines. What that gives you in a corporate environment is some flexibility. Lots of different how can you do this, but if you for instance had a department that now all of a sudden all of the seats in that department are full and you need to put 2 or 3 employees in a different floor, different building, different whatever, you can put them on a different VLAN and they'll be in the same broadcast domain. And broadcast domain is the key. Broadcast domain, we're now talking things at layer 3. So when we create VLANs, the computers that we put in those VLANs can communicate with everybody that's in the same virtual local area network, but not the other machines that are connected unless we use a router. So we're going to incorporate the layer 2 technology, and then we're going to do some layer 3 isolation. And we'll try to go through, when I do the demo, try to go through that router on a stick. You've got a lab to do that. It's kind of a neat thing to do. So the topics here, the CCNA topics in this chapter, what is a VLAN? VLAN, virtual local area network, and again, when you see VLAN, think subnet. And when you think subnet, you're going to have to think, in order to make these subnets communicate, think router. We're going to use a single router, and we're going to go through another kind of cool thing about the routers is we're going to create sub-interfaces, virtual interfaces. So we're going to have a single physical interface and have multiple IP addresses on it. You'll find out you can do the same thing with a Windows server. You can have multiple IP addresses on an XP machine or a Windows 7 machine. They won't route. A server machine will route, so we can have multiple IP addresses on a single interface and actually use that as a router. So you can do routing with those things. VLAN memberships, what we're going to do, what we're going to find out is that the ports on the switch are the things that are on the VLANs. The computers that are plugged into it have absolutely no idea that they are a member of the VLAN. So the switch is going to take over the management of this thing. Now, having said that, and I don't think I really cover it in here, they don't cover it in this one, there is one exception to that, and that is if you have voice over IP. Voice over IP, an individual port can be a member of 2 VLANs, one called the voice VLAN and then one which is going to be called the native VLAN, which is the untagged. And I'm throwing out some terms that I'm going to try to cover when we go through this thing, tagged and untagged, those kinds of things. Got a picture of what actually happens to the frame, why we call it tagged and untagged. In the terminology, Cisco, when we get to the term trunking, Cisco uses the term trunking. Everybody else uses the term tagged. Tagged probably a better word for that. But VLAN memberships mean that the port is a member of a VLAN. which means that it can communicate with everybody else that's on its VLAN. It can't communicate with any other VLANs, just like subnet. If we said subnets, we're a member of a subnet based on our subnet mask and our IP address. And we can communicate with all the other people, computers, machines, devices that are on that subnet as long as we're connected so that we can communicate at layer 3. But we can't, without some other device, communicate with other subnets. So again, VLAN, think subnet. VLAN links, we'll look at that, and that's the one we'll do a demo on. VLAN links, when we connect these things together from switch to switch, and the advantage of this is, when we talk about we can have somebody someplace else, we can have a VLAN faculty on this switch, we can have a VLAN faculty on the switch in room 108, in the one in 109, and the one in the faculty office. All those machines are members of the same VLAN, which puts them on the same subnet. We have to have some way to communicate with that. So we have to create a language, and the language that we're going to use is called 802.1q, which is a standard that's used. Cisco in the beginning created their own what's called ISL, and you'll see a lot of labs that say ISL, and you'll try to do it on a switch and said there is no ISL because they don't use it anymore. Frame tagging, and again, in the Cisco world, we're going to call those things trucks. What a frame tag does is when we have this VLAN, this machines on this VLAN, and the information goes into the port that we have now given the membership in that VLAN, and it goes off of the switch, it gets a tag that says, hey, this information should go to all the computers, all the devices in VLAN 10, VLAN whatever. I'm going to have one here in a minute, do colors, that it works out a little bit better. VTP is a VLAN trunking protocol, automatically will set your switches up for you. It's a good thing and a bad thing. It'll automatically set your switches up for you, but if you mess up, it'll automatically set your switches up for you and destroy everything that you've done. So you need to be really careful when you use this program. It's really a cool protocol, and we'll go through how that works. And you have a homework question for next week of how that works. And that homework question that you have next week for how that works, I had on my CCNA test, so it is one that really has. I had that question. The last person that I knew that took the test had that question. That's a switch question that you're probably not. I wasn't prepared for when I took it. I really messed it up. I'll admit that. Last guy that took it was prepared for it. He didn't mess it up. Trunking allows traffic from all the VLANs on a particular port. Because if we tagged these things and gave them tags, if we couldn't send the tags to the next switch, it wouldn't know where to send it to. If we tagged it to go to VLAN 10 and then it all of a sudden can't go across the connection, the wire between switch A and switch B with that tag, what good is it? When it gets there, it doesn't have the tag. Plus the fact that there's some other processing that goes on when we use a router. We're going to have it to be a trunk port. It's going to have the tags. Computers don't know what to do with tagged frames because they're not standard. The switches know what to do with tagged frames. So the tag tells each switch where to send the traffic within that VLAN, within that subnet. And again, I'm going to keep saying that because when we talk about these things, we want to VLAN think subnet. That's what we're really talking about, is isolating our network by using the switches to simplify things. Inter-VLAN communications. Virtual local area networks, a logical grouping of network users and resources connected to administratively defined ports on a switch. Man, that's a mess of a statement. And what does that mean? A logical grouping of network users. The logical grouping of network users, we're going to take all of the students, all of the faculty, all the admin, all the bookkeepers, all of the administrators, all the whoever's, and we're going to put them on a subnet. And then we're going to, the administratively defined ports, we're going to go into this, and we will go through how to do these things. We're going to go into this switch, and we're going to type the command in the config T, VLAN 20, VLAN 10 or whatever, and then we can name it. VLAN 20, name admin. When we do that, we're then going to go to the ports that the admin subnet are connected to and assign them to VLAN 20. And then we're going to go to the next building or the next room or the next switch and do the same thing with the same VLAN name. The same VLAN name, the same VLAN number. The numbers are what are important. The names are just descriptive for you. And we're going to do the same thing with the ports for the admin guys that are in that room. The students that are trying to hack the admin, I always try to do that, we're going to put them on a different subnet, a different VLAN, VLAN 50. And we'll name it students, and we'll put ports that they're connected to on those switches on VLAN 50 in each of the rooms, and they can communicate with each other. They can't communicate with the admin guys unless they go through a router. And we can prevent that. Next week we'll prevent that by using access control lists, because on the router we can use access control lists to say, not only can't you communicate through the switch because we've now isolated you in broadcast domains at layer 3, we're going to filter what you can actually, where you can actually go. And you've seen some of that around here. So what they do, smaller broadcast domains, layer 3, broadcast domains layer 3, again, subnets organized by, and this is the way we can do it, location, function, department, application, or protocol. Location, if we have some people in, well, maybe have a bookkeeper on each floor of your 30-story building. And you want all the bookkeepers to be on a single subnet. We could go into each switch on each of the 30 floors and assign the port that the bookkeeper's computer's connected to the bookkeeper's VLAN, the bookkeeper's subnet, and then they would all be on the same subnet. They'd be in the same VLAN. So again, think of it, lots of flexibility in this thing, in the use of VLANs. And these are some pictures before VLANs. Before VLANs, we've got the hubs here, three hubs, first floor, second floor, third floor, and we really haven't done anything radically different, except here sales, all these sales guys would be on the third floor, and all the engineering guys would be on the second floor, and all of the HR would be on the first floor. We don't have a whole lot of flexibility if we want to put an HR person in the engineering department. They're going to be in the engineering subnet, because we don't have the ability to go in and on an individual port say, oh no, you're on a different subnet, which is what we can do with switches. Switches, in the switches here, and the colors represent the different VLANs that we can do on this thing. First floor, second floor, third floor. We have sales, and here we've got salespeople on each of the 3 floors, HR on each of the 3 floors, and engineering on each of the 3 floors. We have to go through and do some other configuration, obviously, in order to make this thing work, but we do have that kind of flexibility. It allows you to grow and keep people grouped together network-wise so that they don't have the ability to sit back and maybe run a sniffer, run a man-in-the-middle attack as readily as they would, because we get a little bit of isolation. There is no single answer to any of this stuff. There's only trying to make things smaller. And we talk about broadcast domains, and I think that maybe in his book, at least in his presentation, he said that the maximum, Cisco says the maximum number of devices on a broadcast domain is 500. That's probably a little excessive. Practically speaking, 200 to 300 machines. Now, one of the issues that we get into when we talk about these kinds of things is we think in terms of the network that you set up at home or the network in this building, which is not a very big network. We still have isolated a lot of things. We've isolated things because of students. It just works better. Isolate them even more in virtual machines when we get into the security classes, because we put some things on there that we don't want on the physical machines. What would happen years ago, when everybody was on the same subnet, which meant that you had NetBIOS connectivity, is that you would get people in Windows classes, for instance. People in the server class would connect to and disturb the people that were just starting out in the client class, because everybody starts out with the same password, so they would do really clever things like connect to their machines, put stuff on their desktops, shut the machines down, things like that. Isolation prevents those kinds of things. That's kind of a basic example, but you get the idea of, if we can isolate, we can create a more effective, more usable network to where the few people that are trying to do odd things aren't able to do it as readily as before. This is a picture that I think is kind of good because I talked about numbers. What we have here is a picture, and we have ports with different colors on them. We got the blue ports, the pink ports, and the white ports here are a special case. Those are the ones that are going to be the trunk ports or the tag ports. What happens is we go in and we assign these ports to the pink ports. A computer on the pink ports can talk to all of the other computers on the pink ports, but not the ones on the blue ports. The ports colors would be the VLAN numbers. When we go out of the switch into the trunk port that connects machines to machines, the white ports, a tag is put on because the management of the switch knows where it came from. A tag's put on and said, hey, this is a pink port. It goes down to this second machine and the second router or switch here, and there is a computer connected to the pink port. It'll send that traffic out the pink ports to that machine. It won't send the information out the blue ports. Some other things that he discusses a little bit later in the chapter is called pruning, which says that the switch is smart enough that if it doesn't have anything, this switch down here doesn't have anything connected to the pink ports, tells the other switches, hey, don't send me any pink port traffic. I don't have anybody here. Saves a little bit of bandwidth by not sending traffic someplace where it's not needed because it's not there. So the blue here could be like VLAN 10. The pink could be VLAN 20. When the VLAN 20 information goes into the switch and goes from switch to switch on a trunk port, and we have to configure these things. That's what we're going to do in the demos. We have to tell it what kind of port it is. We have to specifically tell the system that, hey, this is a trunk port. I digress a little bit. We kind of have to tell the system this is a trunk port. Cisco devices are set up so that if you plug a switch into a switch, it'll do an automatic negotiation and become a trunk port. Pretty convenient, huh? Pretty dangerous. We get hacker Dustin in here that brings his switch in and plugs it into our switch because we haven't done the port security configurations. And his switch negotiates a trunk port. And then when we get into the VTP configuration, we're going to go through how to make all this stuff get sent automatically. And now all this stuff gets automatically, his switch gets configured, and golly, he now has access to all of the VLANs. All he does now is goes and puts the port that he plugs his computer into on the, I don't know, let's say on the people that on the payroll VLAN. So now he has access to that local area network without going through a router. So there are advantages and disadvantages, and you know about that. There's lots of management that you can do with switches. There's lots of things that you can undo with switches. And when we get into the automatic thing, if he had configured his switch so that if he just really wanted to be a pain in the rear, and he knew how many changes had been made to our switches, and he made one more change to his switch, he could plug it in and it'd change everything, wipe out all of your configuration. Yeah, I need to be careful about what you do with these things, about what they can, who can and can't plug into it. Automatic and what Jeremy Chiara says on this auto stuff, if you have automatic stuff with Cisco, you ought to not do it. what we can do, and one of the first things that you should do on a switch when you get it, is to turn that automatic stuff off. Because most of the ports on the switch, are, except the ones in the NOC, are going to be connected to computers. So we can change those to tell the switch that, hey, only expect an end device, a computer or a printer or something that has an IP address on that, with a switch port access command that tells it it's an access port. We're going to have two types of ports, access ports and trunk ports. If we tell it that it's going to be a computer only and you plug a switch into it, say, no, you can't fool me. I'm not going to negotiate for a trunk. So you can do those things. Logically groups users, and this is kind of the same stuff, VLAN Foundation. Segments, broadcast domains, which is what we want to do. How many computers do you want in a broadcast domain? 200 to 300 is probably about it. And again, subnet correlation, VLAN, think subnet when you talk about that. Access control, quality of service. Quality of service goes into voice over IP, which you need to know that that's what it's for, but is beyond the scope of what we will do in a CCNA course. This is the flexibility, and these are, we got the pink guys here in building A, and the blue guys in building B, and we got one blue guy in building A, and then a couple of pink guys over here and an IP phone. And again, the IP phone is the only time that you can have a port assigned to more than one VLAN or more than one subnet, because you want your voice to be separate from everything else. There are softwares available that will intercept voice over IP traffic if they're on the same VLANs and record the conversations. You probably don't want that to happen in any environment, particularly in a corporate environment. And that goes back to the same thing that if Dustin was able to plug his switch in, what could he do? He can now, golly, let's put something on the voice VLAN and just sit there and watch the traffic and record the conversations. So, yes, there are advantages, there are configurations, and there are pitfalls in all of these things. These are the switches. Each segment has its own collision domain. In a VLAN 1, 2, 3, 4, all segments are in the same broadcast domain. And that's a standard switch configuration, right? The advantage of switches are each port creates its own collision domain. By default, switches don't create broadcast domains. When we go and configure VLANs, subnets, they create broadcast domains. Simplified network management, I think we've covered a lot of this already, provides a level of security over a flat network because we have now isolated the students from the faculty, from the payroll, from the big bosses, however you want to do it. But you've given yourself some degree of security. And what you're going to find out when we get into the security classes, this is part of it. Layer 2, anything you do at Layer 2, you don't have to do at the other layers. There is no magic bullet for security. There is no killer app to make a network secure. You can make a computer relatively secure simply by turning it off, but it's not very useful. We can make our network a little bit more secure. We talked about port security on Monday. We can make it a little bit more secure by making it such that, set on the Cisco side of this room, we've done that. James didn't bring his laptop today because he knew he couldn't plug it into the wire. Just kidding. But if he did, it would shut the port down. Port security. And I guarantee you, if somebody shuts down the port that they're connected to and they can't get to the internet or to the Facebook or to the whatever, you're going to know about it. And you're also going to now know why it happened. If somebody comes in and somebody in the night class says, what if I plug in a wireless access point? Is that going to shut it down? Absolutely. Because when those wireless NICs start communicating, guess what? They're going to have a different layer 2 address. Excuse me. Switches get layer 2 addresses when it comes into the switch. As it comes in, it builds its MAC table. And in this thing, we build a MAC table, and we can use some commands that will automatically determine it. Because if you've got 3,000 computers, you don't want to sit down at each of those switches on each of those 3,000 ports and type in the addresses. The sticky command will take the MAC address of the first computer. Now, you're going to have a little bit of control of the first computer that connects to that port. So once you've done that, you're in business. It becomes part of the configuration, which also means that once you've got them all right during the running config, you're going to have to save the running config to the startup config, because if you have a power failure, the switches are going off. One of the things that you may have noticed, should notice, will notice at least sometime in the future, switches don't have any power buttons on them. The way you turn them on and off is to unplug them, or at least the Cisco switches don't have any power buttons on them. Flexibility and scalability, we kind of have seen that in some of the, I think, some of the illustrations. What can we do? Given that, and given what we did with spanning tree, that a couple of you missed, we could really create some flexibility and reliability, couldn't we, by having those multiple physical connections, and now we can put users wherever we want them to be physically without having to worry about running a wire to them. So that gives you the flexibility in those areas. Broadcast control. Broadcasts are in every protocol, bandwidth and broadcast, and eventually that's what the 500 is about. And eventually you get so many machines that the broadcasts kind of overtake everything else, which is kind of like building a hub on a much larger scale, because in a hub, if we go back to it, for Ethernet, a hub, we had collisions because it was carrier-sense multiple access collision detection to get access to the media. We're eventually going to get so much bandwidth, so much broadcast traffic in a Windows machine. Any machine will eventually do broadcast. There are some things that they just do broadcast with. How do you find the MAC address? What kind of a protocol? ARP is what kind of a protocol? Can't believe you couldn't answer that after we're talking about broadcast. It's a broadcast protocol. What does it say? Who has whatever the IP address is? And it sends that to everybody because they don't know who has that IP address. If it did, it just goes straight there. Broadcast protocols. A number of broadcast protocols are available. So creating broadcast domains can become a big deal. Versus a flat network. Flat network, switch, hub, doesn't matter. Broadcast, layer 3 broadcasts are not stopped by a switch. They go out every port of the switch. VLANs and broadcasts, VLANs do create broadcast domains because they create subnets. This is just a flat, excuse me, the flat structure here. Broadcasts go out all the ports. Layer 3 broadcasts go out all the ports. There are layer 2 broadcasts. So layer 3, each of these things is going to be there. Flat network problems, and we've, I think, addressed those a little bit in the previous chapter. Security problems, and one of the biggest security problems is people come in and just plug into your switch. Take the wire out of the computer and plug it into another computer. What this does, and we can do that with the port security configuration. What the VLANs do are the things that we've talked about, is not putting everybody on the same network, the same subnet as the payroll people. I always say payroll because that's the thing that kind of means something to everybody. Somebody can pay, if you could change your pay rate, would you do it? Yeah. You bet. So what we'll do is put them isolated so that you can't change your pay rate, because you would. I would. Wouldn't you?
Well, to me, what's suspicious, you would have to change quite a few others, too.
You changed quite a few others, too, so maybe I'll get one of you guys to change mine, huh? Yeah, give everybody a raise, right? Everybody gets a 100% pay raise now. Layer 2 switches, only read frames can cause the switch to forward all the broadcasts, and it will forward all the broadcasts. Create broadcast domains. Essentially, VLANs do create broadcast domains. That's one of the reasons that we use them. Reduces the broadcast traffic, the ability to add wanted users to a VLAN regardless of their physical location, and we kind of address that in the pictures on the different floors or the different buildings. We can put them on different VLANs. Now we have to configure the switches again to send those tags along. Send those the tags along, and we have to configure the ports that connect the switches together to be trunk ports. And back to, yes, Cisco will do that for you automatically. Packet Tracer won't. Cisco will do that for you automatically. Not necessarily a good idea because we don't want Dustin in here hacking on our network.
Yes, we do.
Yes, we don't. Additional VLANs can be created when the network growth consumes more bandwidth. And it's really, really, really tough to create a VLAN. You go into the switch, go into Enable Config T VLAN 55. Enter. Name. Bad guys. Whatever you want to call it. The VLAN is created. If we have properly configured our VLAN trunking protocol, it will then send that VLAN name and number description to all the other switches that are in this domain, and I'll hopefully go through those and make those terms a little clearer here in a few minutes. All the ones that communicate with each other. All you have to do is then go say which ports are on that VLAN. That's the other disadvantage, and we'll have Patrick hack this time, that if he goes in and decides that he wants to wipe everything out, if he has a configuration change number greater than ours, then say, oh, you've got the most up-to-date information here. I'll accept that, and I'll change all my configurations. So you have to be careful about what you can and can't do. You have to be careful about what you do and don't do, or you can wipe yourself out inadvertently. Really cool stuff, but it doesn't always work. Switch networks. We've looked at these things. This would be a switch network, host A to host D. This is, once we found the MAC addressing, and this is not, can be, I guess we can describe it two ways. One, we're going as a unicast, we're going directly there. That's what switches do for us. If we created VLANs and host A and host D were on the same VLAN, and that was a broadcast traffic, then it would only go from A to D and not to everybody else. Hubs, same picture I think that we had a little bit earlier about what we can do. And this is hubs. We put the hubs, the different subnets, and then when we get to the switches, the different VLANs connected to individual interfaces on the routers, so that we provide that isolation. We can provide that isolation with switches simply by configuring the VLANs. And we can replace those two routers, and if we had more, 3 or 4 or 5 routers or interfaces, with one router and one interface. And that's the thing that's called a router on a stick. We'll look at that one here in a few minutes too, so that we use the individual one in order to do that. VLANs remove the physical boundary, and this is, we have the multiple switches, and these switches could be any place within our network, as long as we can connect them with ports called trunk ports and tag the information. And it wouldn't matter where it's going to go. If we send something from VLAN 2 out this thing, it gets a tag on it when it goes out the switch and says, hey, send this information to all of the switches that have VLAN 2. Once it gets into here, the switch removes that tag, and we're going to look at the tag here in a few minutes, removes that tag and sends it every place that goes to VLAN 2. And when it comes out of the core switch here, the VLAN 2, going to all the other switches, will put the tag on it again. That says, hey, when you get to the switch, send it to all the VLAN 2 guys. And it won't go to the VLAN 3s, 4s, 7s, and so on. The tags are really a big deal. Static VLANs, there's a couple of ways to do that. Static VLANs and dynamic VLANs, we'll put them both up. Static VLANs is where we go in and type the stuff in. And it's really another tough command. We can do the interface range, and if you didn't pick up on that one, interface range can save you an awful lot of trouble. INT space, interface space, range space, fast, FA, 0/1 or wherever you're going to start. And you have to put a space, dash, space, and then a 5 if we wanted to do the range interface fast Ethernet 0, 1 through 5. We'll do that when we set the VLANs up, because instead of going into all 24 ports on all 600 switches and typing them individually, the ranges can help a lot. Same thing when we turn off that automatic. I would just go into, the first thing I would do is go into it and say INT space RA, interface range, because that's unique, FA 0/1 space dash 24, enter, switch port mode access. I've now turned off the automatic configuration and told everything that's an access port, because that's what most of them are going to be. Then you go back and make the ones that connect your switches together trunk ports. But the interface range command saves a lot of trouble when you do the statics. Most secure switch ports assigned to a VLAN, and once we get them as switch port access, we go into, we can do the same range command if we have a bunch of them going the same network, access whatever the VLAN number is. So that we can, and now we've assigned them to that individual VLAN, to that subnet. And they can talk to each other. They can't talk to the other subnets without a router. We'll go through that. Dynamic node assignments is based automatic. It's based on the MAC address wherever you plug it into. This one, it sounds really, really cool, right? And it is really, really cool, except that VLAN management got to have a VLAN management policy server. Someone's got to know where that, what VLAN that MAC address goes to. Lots more configuration here, and you have to have more equipment. You have to have the MAC database. This is one that you are going to have to build if you're going to use that. Generally speaking, how much do VLANs change whenever you get them set up? You may add a few here and a few there, move a few around, but it's not going to change dramatically. It's just like setting up static routes inside your building. How often is that going to change? I don't think that often. Daily? Probably not. If it's daily, you probably want to use that dynamic routing protocol. Access links. An access link, one that a machine goes on, printer goes on, whatever goes on an individual device, can be a member of only one VLAN, unless it's a Cisco phone. If it's a voice over IP telephone, that port, and when we're talking about the link can be only a part of one VLAN, we're talking about the port. The switch is managing the VLANs. The device has no idea what VLAN it's on. The switch takes care of all this management, and it can be a member of one VLAN. That's what an access port does. Unless it's a phone, and you have to configure the phone, it can be a member of two VLANs, then the voice VLAN, and then the thing that's called a native VLAN. And the native VLAN is one that's untagged. So it can be if those are there. Trunk links are not a member of any single domain, but they carry our domain VLAN, but they carry the information, the tagged information about all of the VLANs. So an access port's a member of one VLAN. Trunk port carries the information about all of the VLANs. And this is just showing the trunk, and he's got the red, blue, and the green. So in order for the red VLAN to talk to the red VLAN on the other switch, when it goes out the trunk port, it gets tagged that said this information goes to the red VLAN. When it gets to this other switch, it takes that tag out and sends it to the red VLAN. So these managed switches, the reason they cost a little more than the ones that we go buy, like our Linksys, is because they do a little more. They also have more ports. Frame tagging definition, and I guess we've kind of beat that to death. Used to define the ID assigned to each frame, and that's based on the port that it's connected to on the other configurations that we did, which VLANs we assigned it to. Is removed before exiting the trunk links and access links. Once it gets to the switch, it's stripped off because the devices that we're sending it to have no idea how to handle a frame. It's got some extra information in it. Unless we have, and oh, by the way, yes, you can buy special NICs. For instance, if you had a server and you wanted it to be on all of your VLANs? You could do that, but not with just the $12.95, $5.95 NIC that you buy. You have to have a special NIC that can be configured as a trunk link, because that's the only one that can have all the VLAN information on it. Those are available. This is one a little bit out of focus, but this kind of shows the trunk link, I hope. As you go through here, it's got all the different colors on it. Back to the colored ports. We got the blue, the light green, and the green. All of them go into the trunk port. So all of the information about all of the VLANs from the switches go through the trunk ports. These are the IDs. You need to know about ISL just to know about ISL. I don't think that you're going to see ISL unless you have an older switch, because Cisco doesn't use it anymore. Enter switch link protocol, Cisco proprietary. Has to be a fast Ethernet and a gigabit Ethernet only. And I think you're going to find that all these things are going to have to be on at least a fast Ethernet connectivity in order to be a trunk port. 802.1Q, and when you do configurations, you don't have to type all that in. It's .1Q is what goes into the configuration when we want to use this encapsulation. And this is an encapsulation protocol. The layer 2 switches only support, and you don't have to specify .1Q. Layer 3 switches, when you want to set up a trunk port, it's an automatic, a dynamic negotiation, and so you have to give it, specify the encapsulation protocol that you want to use on the layer 3. Most users are trunking between Cisco and non-Cisco switch, and I honestly between Cisco and Cisco switches now, because ISL is not supported in the newer switches. It's just not there. This is the header information that I promised you. One of the questions that I have seen on some of the tests is, how big is the header? The ISL header is a 26-byte header. That's pretty big. It puts a 26-byte header on the front of our frame. 802.1Q has a 4-byte tag here in the middle. Now, if we sent this frame, this Ethernet frame, to a computer, what do you think it'd do with it? It's a non-standard frame. What's it going to do with it? Toss it out. It's going to throw it away because it doesn't know what to do with it. The switches know what to do with this. So it uses these tags. It's got a 3-bit priority and a VLAN number. That's what goes into the tag. When it gets there, it says, oh, send this to VLAN 20, VLAN 100, VLAN 2000. There's lots of numbers, and there is no rules on what you have to do. One of the probably simplification things to do is when you have subnets, assign the VLAN number as the same number as your subnet number, subnet ID, network address, so that you have some correlations there. There's no requirement to assign anything, except they have to have numbers. They don't even have to have names. Names are just for us. Enter switch link. Means of explicitly tagging them allows VLANs to be multiplexed over trunk lines. Cisco proprietary external tagging process puts a really big 26-byte header on it. The .1Q was a 4-byte tag that went into it. Trunking. Do you like these colors? Trunking, again, we've got the different colors, and this is the same one the other one showed. All of the VLANs can go across, will go across the trunk link. That's the only way we're going to allow the VLAN 2, the red VLAN, to communicate with VLAN 2, the red VLAN from switch A to switch B. If we didn't send that information, then it wouldn't know that it's supposed to go to that VLAN, hence there would be no communication in these things. So trunking, tagging, passes multiple VLAN information between the switches, places the VLAN info into each of the frame. It's a layer 2 feature. Layer 2 feature in that all the red VLAN, the VLAN 2 can talk to the red VLANs, the VLAN 2s, but they can't talk to VLAN 3 or VLAN 4 unless we put a layer 3 device in, because VLANs, subnets. Subnets can't communicate without layer 3 devices. The VLAN trunking protocol purpose is to manage all the configured VLANs across the switches in the internet network, and we'll look at that a little bit. What that basically means is that I go in and set up 112 VLANs on a switch, and the switches can be three varieties. They can be a server where you can make changes to, we can actually create VLANs on it, clients which get the information from the servers and use that information, and the other one's called transparent. Transparent says, well, I'll tell everybody about it, but I'm not taking the stuff that you configure. We can configure our own VLANs. They're kind of isolated switches, but they will relay the information about all the things that we configure. And that's where when I've been talking about, it can be a really good thing or a really bad thing, because Patrick came in with his switch and it's a server. And Patrick's server has a revision number higher than my revision number. So all of my switches say, oh golly, you're more up to date than I am. Let me take your information. And he just wiped out all of my 112 VLANs. And guess where they are? They're gone. Gone for good. So you need to be careful about what you do with these things. Now, you can make a mistake like that. They say that one of the biggest mistakes that gets made by the network administrator is switch goes down, or we need another switch and we got to order one. We don't have time to wait, and we go into the lab, and the lab equipment is used to emulate, simulate, test the actual network. So you take this switch out of the lab, and it's a server, and you plug it into your network, and it has a higher configuration number. You just now put all of the VLANs that are on the lab switch on your entire network. One of the things that it doesn't do is the port assignments. If you, like say you had a bunch of ports assigned to VLAN 10 on various switches, and you wipe out VLAN 10, once you put VLAN 10 back on, all those ports automatically come back on there. So those are there. The way you can avoid that when you do things is to make it, instead of a server, because the server is the only one that sends the information out, make it a client switch. Client can't send out, it only accepts changes. It doesn't make changes. Realistically, what you should do is have only one switch that's set up as a server. Except that if you have a really, really, really big network and you go into the switch, you want to add a VLAN that says, oh, this is a client, will tell you you can't add a VLAN on a client switch. Oh golly, I just need to do that right now. You change it to a server, and it's just a matter of saying, just changing the mode, VTP mode server, and it is one. And you do that, and you forget to change it back to a client. And you do that enough times, you got a whole bunch of servers around these things. So it's something that really is handy, and the professionals that I've heard say, some people swear that they'll never use it again, some people swear at it, some people swear by it. It is a handy thing. You got to be careful. It's like everything else that you do that you can make mass changes to. Be careful before you do it. Now you can do, there's lots of things in networking that are real easy to mess things up real quick. Lots of things. You can do, you can do a lot of things really fast, both constructively and destructively in a network. So this is Jeremy Chiara's words here. Virtual trunk protocol has nothing to do with trunking except that it only works across trunked links. What it does is carries the information. Probably should call it the virtual trunk update protocol, because that's what it does. Keeps the VLAN database synchronized between all the switches in the internet network, creating the VLAN domain. And one of the things that is not on these things, the VLAN database is not part of the configuration. It's not part of the setup config. It has, and if you'll do a dir of flash, once you've created VLANs, you'll see a VLAN.dat. If you want to clear the VLANs, you can't do that by deleting the configuration, the startup config. You've got to delete the VLAN.dat database. So it has a separate database when you try to clear these things. The benefits: consistent configuration. We make a change on the server and it sends it to all of the other either servers or clients in the entire network. So if we add a VLAN, poof, that VLAN gets added to all the switches. That's kind of handy. If we do something wrong, poof, all those changes get made to all the switches. Permits trunking over mixed networks, accurate tracking, dynamic reporting, plug and play. Plug and play in that we plug a switch in, make it a member of the domain, and it now has all of that information. Server must be created to manage the VLANs. By default, all switches are servers. So you're going to have to make the configuration changes if you don't want all of them to be servers. You have to change them to clients. If you want one to stand in isolation with its own VLANs, not talk to anybody else, but just relay the information, a transparent switch will do that. So we have servers, clients, and transparent. I think we kind of have covered that. The server configuration is saved in NVRAM. The client configuration is not saved in NVRAM. The transparent saved in NVRAM, but only on that switch. It's not sent anyplace else. Server default, minimum of one server for a domain. Client receives the information, can't make changes, and if you try to and do those things that we say, make one a client. Try to add a VLAN on a client machine. Gives you, and you'll see the error message. Says you can't add it because it's a client machine. Transparent doesn't participate in the domain. To make changes does participate in that. We'll relay the information. That's because if you have a transparent switch between you and some other client, for instance, further downstream, you want that information to get there. It won't affect the changes on that switch, but it will send the information on down the line. This is a router with individuals. We have the three interfaces here, and what we're going to get to is sub-interfaces, which you can do on a router. Instead of having one with three, and we could do that, couldn't we? We could have the three interfaces plugged into the switches, and eventually you're going to have interfaces on your router. What we can do instead of that is to create sub-interfaces, and this is another one. None of this stuff is really difficult to do. You just got to know what to do and when to do it. We'll go into interface fast Ethernet 0.10, for instance. It will now create, when you look at the line on the router, it's going to say sub-IF, sub-interface. I have now created a virtual interface on a physical interface, and I can give it an IP address, and it will act as part of the router. You can put a number of those, and how many can you put on depends on how powerful the router is, obviously. How many things can you actually do with that? Creating VLANs and assigning switches ports to it. We talked about that a little bit earlier. VLAN, bit, and then you go to the port range, and I would go to the port range, or you go to the individual switch port, and just switch port, access, VLAN, whatever. Make it an access port. This is too many accesses, right? Mode, switch port mode access says that only a computer is connected to it. Remember that a trunk port's not a member of an individual domain. The access ports are. And then you tell it which VLAN you want it to access to get to. That's just the way the configuration's set up. You can't really change those things. Configuring the trunk ports, the ones that are connecting the routers together, make them manually configured as trunk ports. Interface, range or interface, fast Ethernet 0/1, enter, switch port mode trunk. It's now a trunk port. You have to do that on the other end also. And you want to do them manually. You don't really want odd-O negotiation to work on these things, so it can cause you some problems. Enter VLAN routing, the router on the stick, or some kind of routing. What we do with the router on the stick is we make the port from the switch, a trunk port, and on the router, on the sub-interfaces, we put an encapsulation of .1Q on it so that it recognizes the VLAN encapsulation and knows what to do with the packet once it gets there. Configuring this thing, configuring VTP question mark, and again, please use the question mark in the tab key. It'll save you some time, particularly if you type like I do. I get going too fast. But the tabs are wonderful. When you take the CCNA, see here we're going to if to when. The question mark help screen works. The tab complete the command works. So the things that you've been using on either physical devices or in the simulators work the same way on the test. You can use all of those things. This is a 1900, be a really old switch. VTP server. We're in the config VTP server. We just made this thing a server. VTP domain name. When we create these things and we want VTP to communicate, they do have to all be a member of the same domain. The domain is case sensitive. So if we typed VTP Skyline all lowercase and VTP domain Skyline all lowercase, VTP domain Skyline with a capital S, then the capital S Skylines would be one domain and the lowercase Skylines would be another domain. They won't share information with each other. They'll only share information in their own domain. You can put passwords on these things if you want. That would keep Hacker Patrick from plugging in and doing the auto negotiation kind of deal. So you can do those things. Inter-VLAN communication, and this is going through, I kind of want to do this in the demo. This is just showing the different VLANs, host A, B, and C. Port 1.1Q, port 2 and 3 VLAN 1, port 4 VLAN 10. Each of these ports are on a different VLAN. Port 1.1Q and Fast Ethernet 0.1, we have to make the encapsulation protocol on this thing, .1Q. I want to do that in a demo after the break. I wanted to put this one before that one. Some basic commands. To view the port VLAN membership on a switch, show VLAN will give you a little table of which ports are on which VLANs. You can see that. Show interface trunk if you want to know which ports are trunk ports. Show INT trunk. It will give you a listing, and we'll look at these things when we do the demo, if you'll remind me. Which ports are trunk ports? Everything else is going to be an access port, we would hope. Show MAC address table. What MAC addresses are on which ports? Show MAC address table. Show VTP status. This is one that's really handy. This is one that when you do the test you will have to use in order to answer the switch question. And that's what they call a simlet. It's a topology that they ask like 5, 6, 7, 8, 9 questions. I think 5 is what they ask on this, 5 questions about it. Kind of like the hotspots that I've been giving you. Those are, you'll see things like that on these things. Show CDP neighbors. Show IPR, maybe. Show CDP neighbors if you want to know what's connected. What you can do is CDP neighbors, what you can do is show VTP status on this thing, tell you where the update came from. Show CDP neighbors. If you do the detail, we'll tell you what IP addresses are associated with which names of the devices and the device types. The device types obviously show CDP neighbor. Show CDP neighbor detail tells you which port and which IP addresses, if you recall that from last block. And those are other examples. Are there questions? I want to stop here and then take a break and then do demo. Hopefully do a demo of this thing. See if I can get through it. Questions? Let's take a break.